All right, Algebra 1, Lesson 12.6, dividing polynomials. So let's start with our warm-up. So when you see m squared n divided by mn to the fourth, you can rewrite that as let's see if I can write, sorry, as m squared n divided by mn to the fourth. And then we can just cancel whatever we need to. So we get m over n to the third. On the second one, we can do a similar thing. We can rewrite it as 2x to the third y squared divided by 6xy. I can simplify this and take away one of those, take away one of those. So I'm left with x squared y over 3. Okay? Similar process on the next one. I'm going to write it as 3a plus 6a. So I'm writing them as rational expressions over 3a squared b. I'm going to factor the top, so I'm going to pull out a 3a, and I'm left with 1 plus 2a over 3a squared b. Now I can cancel those 3's, I can cancel one of the a's, and I'm left with 1 plus 2a all over ab. And you can't cancel those a's. That was my answer here, that was my answer here. Okay, now we have to factor the expression. So this is our guess and check. Now we do have a leading coefficient, so we know one has to be a 5x and one has to be an x. My factors of 12, I can either do 6 and 2 or 3 and 4. I could do 12 and 1, but I think that would be too big because I want to make 16 in the middle. If I do a 2 here, that my outer would make 10x, and then I know that 6 times 2 is 12. So if I have a 6x in the middle and a 10x on the outside, that makes my 16x. So that would be how I would factor that one. On this next one, because it's such a big trinomial, I want to check if it's one of those perfect square trinomials. And remember, the rule says if the leading term is a perfect square, so it is 4p times 4p, the last term is a perfect square. And then if I take one of these times one of these, so 9 times 4p would be 36p, and I double it, does that make the middle? Well, 36 times 2 does make 72, so I can factor this as taking one of these, it's going to be a square, and then I take this sign and stick it in the middle. So that's one of those perfect square trinomials that saves you the time. So today we're going to talk about dividing a polynomial by a monomial or a binomial, and then dividing using something called long division, which long division is very similar to how you do it with regular numbers. To divide a polynomial by a monomial, you can first write the division as a rational expression, which we kind of did in the warm-up, and then you can divide out each term in the polynomial by the monomial. So let me show you what I mean by that. So if I have the expression 5x cubed minus 20x squared plus 30x divided by 5x, you can write it as an expression like I did in the warm-up. And then since it's a monomial in the denominator, you can split up each term by placing it over the 5x and carrying these signs down. Then you can simplify it individually. So the 5 and the 5 cancel. I have one of those left, so I'm left with x squared. 5 goes into 24 times. The x, one of those canceled, so I have a 4x. The 5 goes into 36, and my x's cancel, so I'm just left with x squared minus 4x plus 6. So division of a polynomial by a binomial is really similar to the division of whole numbers. So if I had, let's say I had 168 divided by 3, what you would do is you could factor that, and then you could cancel those 3's. So that's how you get your answer. With polynomials, it's really similar, and we've kind of been doing this. You factor all the parts, you cancel anything that's in common, and you're left with whatever after simplifying. So this isn't anything too new. Technically, we've been doing rational expressions by simplifying. We've been dividing them already. So if I want to factor, I want to factor the top first, so I know I need an x and an x. And if we're dividing, I would suggest that one of them is going to be the x minus 3, as long as it works out. So what can make up 15? Well, 5 and 3 can. And how do I make 2 out positive 2? I need a positive here and a minus here. So in fact, those cancel, and I'm just left with x plus 5. So another similar process, we have to factor both the top and the bottom this time. So I'm going to factor top and the bottom. Now I know that I need a 2x and an x since my leading coefficient is a 2. I'm going to need an x and an x. My factors of 4 that make 7, I could do 2 and 2. That doesn't make 7 though. I could do 4 and 1. Or actually, sorry, I need to take this into account. So if I did a 4 with this outside one, I'd have 4 times the 2x, which would give me 8x. And then I could have a 1 here. So this could be my minus and this could be my plus. On the bottom, if I did 3 and 4, I could make -1 by making this negative and this positive. So those cancel and I'm left with 2x plus 1 over x plus 3. So if you guys notice, what I like to do sometimes is if I factor one part, like I did the top, I always try to like see if one of those is going to be one of the factors on the bottom. So I see if that works out. It can save you time factoring the other one. It doesn't automatically mean it will. It just sometimes that makes things go a little bit faster. So just a helpful hint, make sure you put each term of the numerator over the denominator only if the numerator is a monomial. If that means just a single term. If it's a polynomial like what we just did, for example, this one, you want to try to factor. So only in that first example could we split up every term because the bottom was a monomial. Okay, we're going to talk about long division. Recall that you've used how to use long division for regular numbers. Is over here, if I have 345 divided by 23, I see how many times 23 goes into 34. You know, this is the process of long division. It's very similar with polynomials. So if I have this big polynomial divided by x plus 2, basically what you're doing is this is your dividend, this is your divisor, and this is your quotient. So I'm going to walk you through this process here. What's going on is you're figuring out how many times does this first part of the divisor go into the first part of the polynomial in the dividend. So for example, x goes into x squared. I need to multiply by x to get x squared. So that's kind of the first step. So let me walk you through this. You want to write the binomial and the polynomial long division form. You want to divide the first term by the first term of the divisor. Then you're going to multiply through and subtract like you would in long division and repeat the process. So let me show you. Okay, so when we're taking x squared plus 10x plus 21 divided by x plus 3, we write it like this. What you want to do is you want to see, okay, how many times does x go into x squared? Meaning, what do I need to multiply x by to get x squared? Well, the answer is x, but we write it up above where it's the same degree. We don't write it above the squared since it's an x. So what you do is you take that x, multiply it by this first x, so we get x squared. Then you're going to multiply it by the x or the plus 3. So that becomes plus 3x. Now, just like normal long division, you're going to subtract this whole quantity. So x squared minus x squared is 0. 10x minus 3x becomes a 7x. In long division, you bring down this next term, so we're going to bring that 21 down. Okay, next step. We want to figure out what do I need to multiply x by to get 7x, because x is my leading term out here. Well, I need to multiply it by a 7, so I'm going to do plus 7. Now I'm going to take that 7 and multiply it by the x out here, so I get 7x. I also need to multiply it by 3, so I get 21. I'm going to subtract that quantity, so 7x minus 7x is 0, and 21 minus 21 is 0, so I have no remainder. So my solution, when I divide it, is just x plus 7. Now I know you could get the same answer by taking this and writing it as a rational expression and factoring and canceling out, but you do need to understand this process of long division of polynomials. This kind of walks you through every little step. I thought it got a little wordy, so I kind of just did it right there for you. Let me show you another example, okay? So if I have x squared minus 2x minus 8 over x minus 4, you could factor, but it wants us to use long division. So I need to do x minus 4 divided by x squared minus 2x minus 8. So what do I need to multiply x by to get x squared? Well, I need to multiply it by an x, and I write it above that other x. So x times x is x squared, and x times minus 4 is a minus 4x. Now I'm going to subtract this quantity. So x squared minus x squared is 0. A minus minus 4x makes a positive 4x. So a negative 2x and a positive 4x becomes a positive 2x. I need to bring that negative 8 down because there's a negative 8 in front. Now, x times what equals 2x? Well, times a positive 2. So positive 2 times x is 2x. 2 times negative 4 is negative 8. Now, when I subtract this quantity, 2x minus 2x is 0. Negative 8 minus a minus 8, this becomes a positive, so they cancel, so I'm left with 0. So my answer is an x plus 2. That's all that's left over after you divide it out. Sometimes the divisor is not a factor of the dividend, so the remainder won't always be 0. For example, the last two we did, our final step was a 0. If it's not, what you do is you write the remainder as a rational expression over the divisor. So let me show you. Okay, so what we start off by seeing x into 3x squared. So 3x times what equals 3x squared? Well, I would have to multiply x times 3x. So I write it above this. So 3x times x is 3x squared. 3x times 5 is a positive 15x. Now I'm going to subtract that quantity. So I have 19x minus 15x, which becomes a 4x. I'm going to bring this 26 down. X times a positive 4 makes 4x. The 4 times the 5 gives me 20. When I subtract it, I'm going to get a 0 here, but I'm going to get a 6 here. So I have a remainder of 6. So here's how you write the answer. You take what was on top, and then you add the remainder divided by the divisor. So it's written as a rational expression. Okay? Sometimes you'll need to make a placeholder if a term is missing. So you'll use a 0 coefficient. And this is making sure that you've written the polynomial in standard form, meaning largest exponent to smallest exponent. So let me show you what I mean by that. If I have the term, or the polynomial, x cubed minus 7 minus 4x divided by x minus 3, I want to rewrite that in standard form, so decreasing order from the cube to the x to the minus 7. Then when I go to write it, to divide it out, I need to put a placeholder for the x squared, and it's a 0x squared because it doesn't actually exist. But I have to put it there as a placeholder because when I go to divide, here's why. So x times what equals x cubed? Well, an x squared. So I need x squared times x is x cubed. X squared times a minus 3 is minus 3x squared. When I subtract it, I get 0 here. A minus and a minus makes a positive 3x squared. So now I need to multiply this by a positive 3x. So positive 3x times x is 3x squared. 3x times a minus 3 is a minus 9x. When I subtract the quantity, I get a 0 here. This becomes a positive 9. So that makes it positive 5x, because a positive 9 and a negative 4 is positive 5x. I need to bring my negative 7 down. X goes into 5x. I would have to multiply by a positive 5. That makes 5x there. 5 times negative 3 is negative 15. When I subtract them, I get 0 here. And then I will have a positive 15. So once I subtract that, I'm going to have an 8 left over. So I have a remainder of 8. So my answer is written as what's up here? So x squared plus 3x plus 5 plus your remainder over your divisor. Okay? Just be careful. Recall from chapter 7 that a polynomial in one variable is written in standard form when the degrees go from greatest to least. So when you're doing long division, you have to have it written from greatest to least. Do you see how it goes from 3 to 2 to 1 to no x's? You have to write them like that in order to do long division. And if you're missing a term, so this didn't have the x squared part in between the x and the x cubed, you have to put a 0 placeholder in order to do it. So that's something you really want to remember. Okay, and that is all.